This is section 4.3, properties of logarithms. So in addition to the 4 properties we had in section 4.2, we're going to have 4 new ones. The first thing is, if you have a log and you have in your argument, you have 2 things multiplied together, you can split it up into 2 logarithms that have the same base, and you're adding the 2 together. So multiplication and addition go together. If you have a log and your argument is a division, then you are allowed to split it up into a subtraction problem with 2 logs, and they're going to have the same base as you had here. It's always the numerator minus the denominator. Now right here, if we have log base b of something to a power, so if our argument has an exponent on it, one thing we are allowed to do is we're allowed to take this exponent and move it to the front, and it becomes a multiplier, which is nice. And then we have the change of base formula. We've already talked about how your calculators can only handle natural log and common log. So we have to have a way to go into one of those 2 forms so that we could use our calculator if we needed a calculation. And what you do is, if you have log base b of m, in general what you do is you take whatever your new base is, you're going to use it on the top and the bottom, and you take that log of m over that log of b. Now, in practice, we're going to be using these 2 because these are the ones our calculators can handle. And for most of you, you're going to be using natural log because it's the easiest on most calculators. Now, these also work backwards. We also have things that are added together, and if they have the same base, we are allowed to combine them back into a multiplication. If we have 2 things with the same base and they're subtracted, we can turn it back into a division. And if we have a multiplier in the front, we can move it back up to be an exponent. These work in both directions. Now, you're just not going to use this one in the other direction. So it could be done, but you're just not going to see it. Now, there are 2 main types of problems we have. We're going to have some others to do, but mainly you're going to be asked to expand something as much as possible, or you'll be asked to combine things and condense these as much as possible. And they both have very good uses when it comes to solving equations with logarithms. So even though it's going to seem a little bit weird right now and you don't see a point in doing it, we are building up to something where you will see the use of it. All right. So let's expand each logarithmic expression as much as possible. And where possible, we will evaluate the logarithmic expression without using a calculator. So what I have right now is log base 9 of 9 times x. What I have a card here with all the properties on it. These are the ones from this section. These are the ones from 4.2. Right now I have 9x, 9 times x. I have this situation. So this says I'm going to take log base, whatever this base is, so I have log base 9 of 9 plus log base 9 of x. Okay, so we've split it up. That's good. Now let's see if we can simplify any further. You should recognize that we have the same base here and here. Log base 9 of 9, this is the same situation as right here, log base b of b. This first term here, that's 1. So this completely simplifies down to 1 plus log base 9 of x. Okay, so let's expand log base 5 of 125 over y. What I have here is I have a situation where the argument is a division. So I get to split it up with a subtraction, and it's the top minus the bottom. We definitely want to get that order correct. So this is log, this is base 5, so this stays base 5 of 125 minus log base 5 of y. Okay, now we need to see if any of these simplify anywhere. And since I have a 5 and I have a number, whatever that is, I'm going to check to see if this number is a power of this. And it is. 5 cubed is 125. So I'm going to rewrite this as log base 5 of 5 to the third power minus log base 5 of y. Okay, so what I have right here is this situation right here. I have the same base here and here raised to an exponent, and this says it just equals that exponent. So this part right here is 3. So I have 3 minus log base 5 of y. All right, so let's expand natural log of the 7th root of x. Okay, remember that we are going to be turning roots back into fractional exponents. So this is the same thing as natural log of x to the 1/7 power. Now, when we're being asked to expand things as much as possible, we're starting on this side of our properties and going to this side. So right now I have my argument has an exponent on it. So I want to take this exponent and move it down to the front. This is the same thing as 1/7 times natural log of x. Okay, so now you've seen each of our main transformations used in isolation, but in general, they are going to be much more complex. So if you look at this right here, I have fractions. I also have an exponent here with a square root. So I have a lot going on. The first thing I'm going to do is I'm going to use this division rule so I can split it up into 2 different logs. So this is the same thing as log base 8 of the top one, so 64, and minus, because it's a division, log base 8 of the square root of x plus 1. Okay, now let's see if we can simplify. Now, just like before, if I have a number here, no variable or anything, I'm going to check to see if the argument is a power of the base, and it is. This is 8 squared. So I have log base 8 of 8 squared minus log base 8. I'm going to change this to an exponent, and it's x plus 1. You need to put that in parentheses, raised to the 1/2 power. Okay, so now log base 8 of 8 squared. I have this situation where the bases are the same and you get the exponent. So this should be just a 2 minus, and now what I have here is I have log base 8 of something raised to a power, and this property says I can move that exponent down in front. So this is 1/2 log base 8 of x plus 1. You definitely need your parentheses here, because if you don't have it, it's going to be read as log base 8, and then you're adding 1 to that answer, and that's not what you're being asked to do. Now you might wonder why we didn't take this 2 and move it in the front here. Well, we could do that. That's perfectly legal. This first thing is log 2, move the 2 in front, log base 8 of 8. Well, we also know from our properties that if these two things are the same and they don't have an exponent, that's a 1. So this would be the same thing as 2 times 1, which is 2, and that's exactly what we got here. So it doesn't technically matter. You can do that. All of these things are related, and you can generally get one from another bit. Okay,